Okay, this is from pretest 1, question number 10, and looking at the feedback, there's a few people who had trouble with this question, and a few people have been making some errors um, with it, so we thought we'd put up a video regarding it. I'm going to do the question two different ways. Uh, this polynomial expression, um, in terms of factoring it completely, most probably you would look at the thing and identify a common factor of 2 through all terms, and of course a common factor of x. And so we're going to factor out both. We're going to factor out the 2 and the x on this first uh, iteration of this. And of course, in doing that factoring, you're dividing. And so 4x cubed divided by 2x becomes 2x squared. And then the 2x squared divided by 2x becomes plus x. And of course, the minus 12x divided by 2x becomes a minus 6. And then from here, the rest of the factorization, um, we want to look at this quadratic expression in here. And we're going to use that AC method that we talked about in the video on questions number 8 and 9. And just to refresh those steps, you want to multiply AC. You want to identify factors of AC. Um, you want to compare the factors uh, to the B value and select, I suppose. Uh, you want to rewrite um, by um, expanding, I'll say, the B term. We can call it the BX term. Okay? And then finally, you finish by factoring by grouping. So we're going to execute these steps and show you what this would look like. Um, A, of course, is a 2, and C is a minus 6. And so if we do that product, if we do the 2, and I'll just ignore the sign. Sometimes when this method is taught, people include the sign, but I'm just going to call it a 6. And so that's 12. And now I need to identify all the pairs of numbers that multiply to 12. And of course, first and most apparent is 1 times 12, 2 times 6, 3 times 4. And those are all the integer pairs, uh, except for order, I suppose, of factors of 12. And now we're going to compare this list of factors to the b value. And the b value, of course, is the plus 1 right here. This would be b. And with b equal to 1, and then we're going to pick the 3-4 combination because they have a difference of 1. That's how we're selecting that. And then I'm going to rewrite the quadratic expression, and I'm going to write it as 2x squared plus 4x minus 3x minus 6. Now notice a couple things. First of all, I kept the 2x. I just don't throw the 2x away. I don't lose that 2x. Again, we're factoring the expression. We want to maintain all the terms um, out of our factorization. Um, Next, this is what we mean by expanding the middle, or in some descriptions of this method, they'll call it splitting the middle. Um, the order is insignificant. We could put the minus 3x first and the plus 4x second. It does have to be a plus 4x. It does have to be a minus 3x, but you can disregard the order here. Um, Now, from there, we're going to do our factoring by grouping on the 2x squared plus 4x and the minus 3x minus 6. Again, continuing with this factor of 2x. We don't want to lose that. And so as you look at this first pair, they of course share a multiple of 2x. And that leaves me with an x plus 2. So that first pairing that I've got the brace under here, um, they're both obviously multiples of 2, and they both share an x. So I divide out of each term a 2x, and 2x squared divided by 2x leaves you with 1x. And 4x divided by 2x gives you just a 2. Now in the second pairing, they're both negatives. I'm going to factor out a negative sign. Okay? And obviously both multiples of 3. So I'm going to factor out a 3. I'm going to divide out a 3 from each term. And when I do that, I get x minus 2. Close the parenthesis there and close the parenthesis on the full grouping. All right. Now, factoring out that minus 3, of course, this minus 6 divided by minus 3, that's going to make that a plus 2 right in there. And so right here, you see that we have the exact same factor in both the first pairing and in the second pairing of that quadratic that we factored. And because of that, I'm going to factor out the x plus 2 from each one of those. And the 2x minus 3, I'm going to leave the 2x and the minus 3. And so there's a complete factorization, and I'm done. There is no setting them equal to 0. This is not an equation. We're not looking for roots. We're not looking for an x equals answer. The mission here was only to factor the expression. Now, of course, roots or zeros um, of the expression are relative and can be relative in terms of the factoring of the expression. But in terms of what we're asked to do here, this would be our answer. Now, of course, disregarding order, it doesn't really matter what order the terms are in by commutativity. But that's the problem done uh, by a factoring method. Okay. Now, just real quickly, I'm going to run through very similar technique, but we're going to imagine that we didn't observe the factor of 2, right? And pretend we didn't see that factor of 2 in there. And so what we'll do is we'll say, okay, we noticed the x that they all had in common, but we didn't notice that they're also multiples of 2. So in doing that, we would get this quadratic expression. We'd get 4x squared plus 2x minus 12. Okay? Now, of course, that changes our AC method a little bit, because now a is a 4 and c is a minus 12. So if we do that product, if we do 4 times 12, we get 48. And of course, then generating the factors of 48, we have 1 and 48, we have 2 and 24, we have 4 and 12, we have 8 and 6, we have 16 and 3. And we're going to compare these factors, compare this list of factors to the b value. And the b value this time through is 2. So as we look at this pair of factors and look for a difference of 2, we're going to select the 8 and the 6. We continue by rewriting the quadratic expression. Again, keeping that x, don't want to lose that x. And we have 4x squared plus 8x minus 6x minus 12. And now, going with the factoring by grouping, doing the pairwise factoring on each piece, we have, from the first pairing, now perhaps you notice the 4. So we factor out a 4, we factor out an x, dividing out of 4, dividing out of an x from each of those terms. That's going to leave us with an x plus 2. And on the second pair, factoring out a minus, and of course both multiples of 6. So you factor out a negative 6, and that leaves you with a plus x when you divide, and a plus 2 when you divide. We close the parenthesis on that pairing, and we close the parenthesis on the entire expression. And then finally, once again, we identify that we have a common factor between the two pairs of x plus 2. So we factor out that x plus 2. And that leaves you from the first pairing, when you divide out that x plus 2, of 4x. And from the second pairing, when you divide out the x plus 2, you're left with a minus 6. Now, you factored it here, but not completely, because right in here, there's still a multiple of 2 remaining. Um, and so to get a complete factorization would be x times the quantity x plus 2 times a 2 times a 2x minus 3. And there you have the exact same answer we came to the first time. Okay, so the method that you use isn't critical. It should all come out in the wash. Um, and again, the biggest mistake we were seeing is people who were extending further from this point and coming up with an actual value for x. And so you want to be careful of when you're working with an expression where a zero or a root can tell you something about the factoring, but it's not the solution to the situation. So if there's any other questions, get back to us. We'll talk more about factoring tomorrow, um, and be looking at how some of this applies to the